So this time we're ready to talk about the third type of conic, the circle, the one that you're probably most familiar with, so I won't have to go into as much detail. But the definition for a circle would be the set of points in a plane equidistant from a fixed point. Now, similar definition to the other conics we've studied so far, and it does hold true in a very, very simple way. So for example here, if I take a point, and I have some distance there, all of these other points that are equidistant are the points of the circle. The distance that we're talking about there is probably what you assumed, the radius, and the center would be the point HK. So now, if we call this point on the circle an arbitrary XY, when we use our distance formula here, let's see what happens. So I know that R would equal the square root of x minus h squared plus y minus k squared, and that's just the distance formula between those 2 points. And if I go ahead and I square both sides here, I end up with x minus h squared plus y minus k squared equals r squared. And that's the equation of the circle that you probably have seen before. Now, again, the circle and the ellipse are very much related. For example here, if I went ahead and I gave you the equation of an ellipse from what we've just studied, and my A happens to equal B, if my A happens to equal B, then if you remember from graphing the ellipse, we would count left and right the same number of units that we would count up and down. Well, by constructing a shape that way, you end up with the circle. And so if A equals B here, then if I multiply both sides by either A or B, they're the same thing, then what you end up with is what you see up there. The A and B value are just your radius. And so you can think of the ellipse as, you can think of the circle as essentially the perfect ellipse. You're counting the same number of units up, down as you are left and right, in which case you have some nice symmetry there as well. All right, and the last thing we're going to talk about in this video is eccentricity. We're just going to briefly introduce the idea of eccentricity for circles and ellipses at this point to give you just a very, very basic understanding. But the eccentricity is defined as C over A. The C that we're talking about is the same C as we were talking about for the ellipse, right? The distance from the center to the foci. The A is the same as before, where it's the distance from the center to the outside of the ellipse along the major axis. Now, we'll consider the two most extreme cases. I'll look at a circle, which, like I described before, is almost like a perfect ellipse. And then we'll talk about something that is most definitely not a circle. That's going to be something that's really kind of oblong and oval shaped. Now, when you talk about the foci, for something that's definitely not a circle, the foci are going to lie really, really close to the outside edge. The more elongated it is, the closer the foci are to the edge. Almost so that C, which is the distance from the center to the foci, is approximately equal to A, which is the distance from the center to the outside. So if C is approximately equal to A, then our eccentricity is approximately 1. So for the more elongated or imperfect the ellipse is, the eccentricity is going to approach 1. Now for a circle, the foci are actually right at the center. If you think of light bouncing around in that circle, it's going to hit that focus right there in the center. So if the focus is in there, the foci are in the center, then that means that C is equal to 0. The distance from the center to the foci would be 0. There's no distance there whatsoever. If C is 0, doesn't matter what A is, the eccentricity would be 0. So in general, the eccentricity will, for an ellipse or a circle, will always be between 0 and 1. The closer it is to 0, the more perfect it is. The closer it is to 1, the more imperfect or elongated it would be. All right, so in this example, we're going to come up with the equation of ellipse with the foci given and the eccentricity given. So for an equation of the ellipse, once again, if you write down the equation, not only will it help you remember it, but it'll tell you what it is you're looking for. So for the equation of ellipse, I'll need a center, HK, and I'll need A and B. Now, from there, I'll go back and draw kind of what I know. The foci being at plus or minus 5, 0, tell me a lot. It tells me the major axis is X, tells me that C is equal to 5. Also tells me the center is 0, 0. And then to find A and B, I'm actually going to have to go ahead now and go back and look at this eccentricity. I know that the eccentricity is the ratio of C over A, and I know my C value. Is 5. I don't know the A value, but my eccentricity is given as 1/2. So if I look at this simple proportion, I can then conclude that the A value would have to be 10. So our C value is 5, our A value has to be 10. To find the B value, A squared equals B squared plus C squared. We'd have 100 equals B squared plus 25. So B squared equals 75. Putting it all together, the major axis is X, so the larger number, the A squared, goes under the X, and the 75 then would go under the Y since it's the minor axis. So there's the equation of the ellipse with the given information.